In the following tracing, we are going to see the specificities of the programming of the therapies in the VT zone. The first patient, with an episode of monomorphic stable ventricular tachycardia detected in the VT zone. When the VT counter is filled, the first therapy is delivered. It is a sequence of ATP, and you can see that it is successful with the return to sinus rhythm. If you look at the detail of the ATP sequence, you can see that this is the burst and that there is no change in the duration of the intervals between the different stimuli. This is now a second patient with a more recent platform. You can see the initiation of a stable monomorphic ventricular tachycardia detected in the VT zone. The VT counter is filled, and now the ATP sequence is delivered. But this time there is no termination. In contrast, there is an acceleration of the arrhythmia from a stable ventricular tachycardia into a very polymorphic and very fast arrhythmia detected in the VF zone, with detection of an episode of VF. Then there's the charge of the capacitors, and at the end of the charge a shock is delivered with a return to sinus rhythm. So with these two first examples, we can see that in the majority of cases ATP can be successful, therefore can decrease the consumption of the batteries when compared to an electrical shock. Is of course less painful, but we also know that there is probably a detrimental impact of an electrical shock in terms of prognosis. So it is very important to decrease as much as possible the aggressiveness of the therapies. That is why ATP is now clearly the first line therapy for any tachycardia in the VT, but also in the VF zone, up to a limit of 230 beats per minute. But we can also see that in some rare cases ATP can be pro-arrhythmogenic and can modify a stable monomorphic ventricular tachycardia to a life-threatening ventricular fibrillation. Therefore, the way of programming an ATP sequence is very important. In the new guidelines, you can find very precise recommendations on how to program the ATP in the VT zone. First, you should program bursts more than ramps, because the ratio between termination and acceleration, as demonstrated in a previous tracing, is better for the burst as compared with the ramp. So that's a class 1 indication. You need to program at least 8 pulses, between 8 to 15 pulses, with a percentage of 85%. You can program at least one burst for a single episode, but you can program more sequences with a scan step of 10 milliseconds. It means that if the burst is inefficient and there is no charge in the rate of the tachycardia, the next burst will be 10 milliseconds more aggressive than the previous one. You need also to reprogram the readaptive to on. It means that when the burst is inefficient and then the tachycardia has accelerated, the frequency of the next burst will be calculated according to the new rate of the tachycardia. And you will also need to program a minimum cycle length 200 milliseconds. It means that whatever the rate of the tachycardia, it will not have the possibility to pace at a rate faster than 200 milliseconds.